The small cell market is like a train coming down the tracks at us, and we have to meet the challenge because it's inevitable. The traffic growth means that the spectrum will be exhausted, and unless we deal with this, customer experience will be impacted.
So what building blocks are needed to accelerate the rollout of small cell networks?
There's really two major obstacles that we see right now for deploying small cells. One is site access and the other is backhaul. From a site access point of view, it's going to be very difficult and operators are having a lot of trouble getting access to sites at a street level in a large scale. Every single pole, each building side can be a different negotiation and may be very difficult to negotiate with on a city council level to make sure you meet the zoning requirements, the proper size, and that it's something that's deployable and can be operationalized. So that's a very difficult thing, and it's very regional and city dependent. So what operators adopt first may be very regional dependent because of that. Somewhere where it's very easy to get access to sites may be deployed long before something that's difficult but a more advanced market. On the backhaul side, we view right now there's many sites that have no access to backhaul at all. These are non-traditional sites. They're things like the backs of a billboard, a lamp pole, a traffic light, a utility pole, or the side of a building. These aren't traditional sites, so just getting power there will be difficult, let alone having high capacity backhaul. We think wireless backhaul is a very good solution for this and will be a fundamental building block to small cells.
What key performance specs are needed for small cell backhaul?
There's a number of key performance specs required for small cell backhaul. One is the capacity. It's very important because this is a capacity augmentation solution that you have a high capacity backhaul solution. So we think that you need to have speeds in 100 megabits plus for the backhaul. In addition, delay is very important to be able to meet the LTE and LTE advanced standards. And we think sub-millisecond delay is very important. Lastly, because these are often in difficult urban locations, timing won't always be available. So it's very important that there's a synchronization solution from the backhaul, either 1588 V2 or SYNC delivered by the backhaul product.
What spectrum bands are best suited for wireless backhaul of small cells?
We really view that the bands for small cell backhaul is going to be a toolkit approach. There's not going to be one band that's suitable for a network. It's going to be a combination of bands. You'll need sub 6 gigahertz for non-line of sight applications, probably more traditional microwave bands for a lot of the applications, things like 23 all the way up to 60 gigahertz, and then some 70-80 gigahertz for some very high capacity sites and aggregation links.
Does wireless backhaul scale for LTE advanced?
Yeah, wireless backhaul absolutely does scale for LTE advanced. It has, right now, delivers capacities up to a gigabit, which is well in excess of what many of the operators are requiring for a small cell. And there are evolution paths from that as we get higher modulations as well as advanced technologies like compression. We think it's very well suited as well for voice over LTE with the very low delay that's available in the millimeter and microwave bands, so it can meet the requirements for voice over LTE. And for network sharing, the key requirements are that you have advanced Ethernet and switching capabilities, which are available in many of the wireless backhaul products today.
How significant are aesthetics for wireless backhaul products?
Aesthetics are a major role in small cell, perhaps one of the most important roles in small cell. It's what enables the product to be deployed. These are being deployed at street level. They have to be approved by city council. They're often on city street furniture like lamp poles or sides of the buildings. So the size as well as what it looks like is a key element, and it's something that all the companies are focusing on. It's also what's driving a lot of integration and why vendors are looking to integrate the backhaul with the access to minimize the footprint that it takes and to make it as non-noticeable as possible. For this reason, there won't be a single global solution. It's going to be dependent very much on where you deploy it and what aesthetics are required for it to be deployable in that specific market.
When will large-scale rollouts of small cells really begin?
Deployment timing is the million-dollar question. Everyone has an answer to it, but no one's been right so far. 3 years ago, we were saying it was in 2 years. We're still questioning that. What we are seeing now is that there is a lot of evaluation going on, and operators are getting very serious about it. Trials are happening, there's a lot of tenders occurring, and even the very early first deployments are starting to occur. So we are starting to see the first movers in this market. There are still a lot of factors that could cause it to delay, site access being one of the major ones. As operators start to address these hurdles and address the challenges, we think it will start to move, and it is inevitable that the small cells will start to get deployed. It's just addressing each one of the important and difficult challenges first.